Hi, in this video we are going to talk about properties of logarithms. And so there are 7 properties of logs that I want to go through and show you how to use, and then there'll be a second part to this video where we'll use properties of logs to expand logarithms, and then also to take an expanded logarithm and make it a simple logarithm. So let's look at the 7 properties. So property number 1 is anytime you take the log, regardless of the base of 1, that will always equal 0. That's your first property. So anytime you take the log of 1, regardless of the base, that will equal 0. Property number 2 is anytime the log, whatever you're taking the log of, is the same as the base, that'll always equal 1. Oh, and if we talk about why this is true, if you rewrite this in exponential form, it says b to the 0 equal 1. Or think about what the log equals. This means what power do I need to raise b to get 1? And that'll be 0, because anything raised to the 0 power is 1. If you think about this one, it says what power do I need to raise b to in order to get b? And that'll be 1, because anything raised to itself gives you itself. Alright, so then the third property is anytime you have the log of something where the base is the same, but it's raised to an exponent, so similar to property 2, but it's raised to an exponent, then this is just equal to x. And this says, what power do I need to raise b to get b to the x? Well, you need to raise b to the x power. The fourth property is anytime you have an exponent that has a log in it, and the bases are the same, so the base of the log is the same as the base of the exponent, then all of that goes away and this just equals x. When I say all of that, the b and the log of b goes away and that just equals x. So these are your first 4 properties, okay? So then the 5th property is, the last 3 properties have names. So the 5th property is called the product property. And that's when you take the log of 2 things being multiplied. So if you have the log of 2 things being multiplied, you can separate those by creating 2 logs of those 2 things being added. So that's the product property. And then you have the quotient property, which is a log b of x divided by y. You can separate those by subtracting them. So that becomes log b of x minus log by. That's the quotient property. And then the very last property we're going to talk about is the power property. And that's when you have log b of something raised to a power, so we'll call it x to the r. So you have the log of something being raised to a power. Well, by the power property, you can pull that power in front and multiply it by the log. So that becomes r times log base b of x. So these are the 7 properties we want to talk about, and we're going to go through and look at some examples on using these properties. For example 1, we want to evaluate the following. So all of these are logarithmic expressions, and we want to evaluate them using some of the properties we just talked about. So starting with this first one, log base 3 of 3 to the 10th. So this is the property where the base in what you're taking the log of, that base is the same and is raised to a power. And so in that case, your answer here is going to be just 10. So this basically says, what power do I need to raise 3 to in order to get 3 to the 10th? I need to raise it to the 10th power. That's actually our third property that we looked at earlier. So when we defined the 7, that was property number 3 that we used here. Alright, so this is natural log. So in order to figure out what this one is, you have to remember that natural log is a log base e. So this is equivalent to saying a log base e to the 2nd. So this one looks like the last one, excuse me, y'all, I've stopped up today. This one looks like part A, except the bases are different. So the base here is the same as this base. I mean, it's different from the 3. But these bases are the same. And so all of this goes away and it leaves you with just 2. So again, that's using property number 3. That's a 2. My son talks about the way I write my 2's. He don't write the way I write them. He thinks I should write them like this. And he's in kindergarten, y'all. But anyway, so the answer to that one will be 2. So for part C, you also have to recall that log with no base is equivalent to log base 10. So this is the same as saying log base 10, 10. So this is property number 2, where the base and this number is the same, and so that equals to 1. Or you can think of it, 10 to what power gives you 10? 10 to the first power gives you 10. Alright, this one is property number 1. Anytime you take the log, regardless of what the base is of 1, your answer is always 0. And if you want to think about what it means, this means square root of 7 to what power gives me 1? Well, anything raised to 0 power is 1. And then this one is our 4th property, where you have exponent raised to a log and the bases are the same. So all of that goes away and it leaves you with just c squared plus 4. And so this is how you will work these or evaluate these logs using the one exponential using the properties. Let's look at another example. For example 2, we want to use properties to expand the following. And so if we look at this is an L, by the way, if you haven't figured it out. That's how I write my L's when I write log. This says log base 2 of 8 times x. And so which product involves taking the log of two things being multiplied? That would be the product property, which is property number 5. And the product property says if I'm taking the log of two things multiplied, I can expand it by adding those two things. So this would simply be log base 2 of 8 plus log base 2 of x. Now if you have the log of a number, you want to try to evaluate if you can. This means 2 to what power gives me 8, and that would be 3. 2 to the third power gives you 8, so that would be the same as 3 plus log base 2 of x. So that would be your final result. Alright, and then for this one, you have the natural log of 3 things being multiplied, but you still can't apply the product property here. So you just take each one of those and add them. So the natural log of 5 plus the natural log of x plus the natural log of y. Natural log of 5 isn't going to come out to be a whole number, so we can leave it like that, and that will be our final solution. In this example, we also want to use properties to expand the following. So for part A, we have log base 3 of c divided by d. So which of the properties involves taking the log of two things being divided? If you look back at the properties, the 7 properties, and see which one. So the quotient property, yes. The quotient property involves taking the log of two things being divided. And so this will be log base 3 of c minus log base 3 of d. Neither one of these have a number involved in it, a c and a d, so we just leave it like that. So the quotient property says if you have the log of two things being divided, you can separate it by subtracting them. So the same thing here. So this will be log of x minus log of 1,000. However, you have the log of a number, so you want to see if you can evaluate that. So remember, when there's no base, that's base 10. So this means 10 to what power would give me 1,000? Well, 10 to the third power gives you 1,000. So this is equal to log x minus 3. So that will be your final result for part B. On example 4, we want to apply the power property to expand the natural log of the cube root of x squared. And so in order to expand this, we need to first rewrite this. So recall previously, way back at the beginning of the semester, that we talked about how a root can be written as an exponent. Whenever you have a root, then you put in the exponent and it becomes the denominator of the exponent. So this is the same as saying the natural log of x to the 2/3. So we took this root 3 and put in the denominator of the exponent. And if there's no exponent there, it's an understood exponent of 1, so you just put 1 over 3 if that 2 wasn't there. And so now we can apply the power property. The power property says if you have the log of something raised to an exponent, then you can pull that exponent in front and make it a multiplication. So that becomes 2/3 times the natural log of x. And so it's not the natural log of a number, so we can't evaluate it. So we would leave it just like that. And that would be your solution. Okay, I want you to pause the video for a moment and try this problem. So use properties of logs to see if you can expand this. So pause it and try it and see what you get. Okay, so you should have noticed that this is the log of two things being divided, which means you want to use the quotient property. So you should have rewrote this as natural log of x minus natural log of e. However, recall that natural log of x is the same as saying log base e of x. So this is equivalent to saying log base e of e. And then, so now you also have to use another property. Use the property number 2, yes, where the base and its number is the same, then that comes out to equal 1. So this actually ends up being the natural log of x minus 1. Did you get it? Or did you stop here? So if you stop here, you're not completely correct because it's not completely simplified. So you have to remember that anytime you have the log of something that's not the log of a number, you have to see if you can evaluate it. So e is actually a number. Remember, that's Euler's number. It represents 2.71828 and some more numbers. So you have to actually evaluate that. So hopefully you understand these properties. If not, ask questions. Put them in the comments. I will respond. So ask your questions if you have any. If not, go on to watch the next video, which is using properties of logs to expand logs, and also to take an expanded log and write a single logarithm. So that's properties of logs part 2. So go on and watch that video. If you haven't already, make sure you hit the subscribe button, and if this video helped you, hit the like button as well. I will see you in the next video.